All right, now I'm going to spend a little bit of time talking about how we're thinking especially about sedimentary rocks here, because you do have a sequence of sedimentary rocks, and you should have, in your geologic history, yeah, you're going to be talking about how the environment is changing, but ideally you put it all into context of the location where you are. So that's the one thing to remember. When you see all of those layers of rocks right next to each other, they were stacked on top of each other. So you weren't changing your position. However, the environment where you were, like through time, has to have changed in order to deposit those different rock types. So what I've drawn here is a very simple shore face, and then going off into into a deeper marine environment. And I'm going to start out with something like this, with a sea level right here. There's our sea level. And what you want to think about when you have sea level sitting at a relatively constant elevation over time, as you have, and the one thing you want to think about if you're thinking about a marine environment like this is that there will be material, detrital material, and dissolved material, and class of all sorts of rock types that are coming down into the ocean system, let's say, in this case. And so what you want to be thinking about is, all right, so if you have all of this weathered and eroded material being transported into this environment, what do you expect to see along that shore face, going from onshore to further and further offshore? And the sequence that I'm going to give you, this is this ideal sequence that people commonly use when they're talking about how environments change as you move offshore. But it's something you can use to do a simple interpretation of a sequence of rocks. All right, so in general, the closer you are to shore, there's still a lot of energy in the system. As rivers are coming down and depositing, there can be longshore drifts, so you can actually have sediments coming out of river systems, and then because of wave action, actually have sediments that move along the shore face. But in general, you expect to have like moderate, sometimes high energy, but let's say, moderate energy close to shore. And hopefully if you've been on a beach, you know what to expect. You expect to see sand. And so over time, if deposition happens for long enough and enough subsidence takes place, you actually may get a sandstone through time. But right now, we're just thinking about the sediments themselves. Once you start to move offshore, you get to finer detrital materials. And so you might get into something, and this is, again, this is on the order of hundreds of meters to kilometers moving offshore here. But I'm keeping it relatively simple for what we're talking about. So close to shore, think sand. As you move far enough offshore that you no longer have sand deposited, you still have clay minerals that are working their way out there, but they're finer. And so they are going to settle out in a lower energy environment. So energy is decreasing as we move this way. And then eventually you get far enough offshore, if you're in a location where limestone can form, you may start to get a fine-grained limestone forming. Again, this is simplified, but it's a good way to think about the evolution of a marine system through time. So if sea level doesn't change and you have very slow subsidence through time, you may end up depositing thick layers of limestone, of shale and sand, different locations along the shore face. However, if you have a change in sea level, so let's say that we decrease the sea level down to that spot, right? So now let's decrease sea level. So sea level goes down. Right, and this would be where the sea level is regressing from the shore, moving away. But what that means now is that where we originally were forming shale, now we're right at the shore face. So now instead of shale, we would expect to form sand. And once we get further offshore, where we were forming limestone, it is now shallower. And so this might be where we start to see shale. And then the limestone would continue to form, but it might actually be further offshore. All right, so what you would see here, you are no longer depositing anything, or you have dropped sea level, and so you wouldn't change what you see here unless it actually starts to erode. Then you move to this location, you would see a shale overlain by a sandstone. And then here you would see, if you were right here, you would see a limestone underlying a shale. And so you would see an evolution based on the change in sea level. If you drop the sea level further, say we did this, drop it a little bit further, now you would have limestone, shale, but now we're right close to shore, and so you might end up with a sandstone overlying that shale and limestone. And I guess I'm calling this shale this whole time, but really we're thinking primarily of like muds, in clay minerals and silt-sized particles of quartz, most commonly, maybe a little bit of feldspar. And then you move out a little bit further, and limestone might now change, so your environment is depositing, clay minerals and silt-sized minerals and forming shales. So the cool part about this is, in the rock record, if you continue to have subsidence long term, you would record this period of sea level fall because you're going from a limestone to a shale to a sandstone. Conversely, I'm not going to go through the whole process again with rising sea level, and that's a sea level transgression, and sometimes I call it a transgressive sequence. First, if you were down here, the first thing deposited at this location would be a sand. As the sea level rose, now you're further offshore, then it would be a shale. And if the sea level rose again, then you would get a limestone. So by looking at the order of those, you can talk about changing sea level. Now, the other pieces that you have to get at with a geologic history, and I think most of you did get to the point where when you saw nonconformity, I saw uplift and erosion, which is great in order to expose something that was really deep within the earth. But the other thing you have to remember is that that's true, but then something had to fundamentally change in order to start depositing those sedimentary rocks. To deposit and preserve sedimentary rocks, you have to have subsidence. And so you might have subsidence, and if that subsidence continued, then it's deepening through time. So it may be that if it's subsiding faster than it's depositing, you end up with something where it looked like the sea level appears to be rising, and that would make sense. Or no matter what, you have to say subsidence, but then if you see sea level rise or fall recorded in the rocks, that's something you can talk about. So in your geologic history, you should be talking about changing environments of deposition to give you the rocks that you saw. What must be happening at this location in order to get the different types of rocks based on sea level change? And you want to get to the really big picture, and that's where you have uplift and erosion versus the subsidence. So I know I just went over quite a bit, but I want you to be thinking a little bit more deeply when you're talking through the layers in the rock that you guys actually see. So your geologic history, a big chunk of it is going to be describing changing environments of formation and deposition, or metamorphism, if you want to talk about that. But if you're talking about metamorphism, you have to be thinking, okay, wait a minute, if there's metamorphism, the high-grade metamorphism, chances are you should be thinking about a mountain building event that actually caused that metamorphism. Then you have the uplift and erosion. Then you have a shift to subsidence that allows the deposition to take place. And then you can start talking about sea level change during that period of deposition. But what you don't want to forget about is that once those layers, because all the layers that you saw are involved in the folding, after they're all deposited, you've got to start talking about the structural geology. And that's where I want to see those new pieces that hopefully now, based on what we just talked about the past couple of days, that will make more sense. So I'm going to give you guys a chance to rework your geologic history based on the map that you guys created yourselves. And then I also want you to go back and look at the geologic history that you wrote for the quadrangle, thinking about this as you write about it. And what you never want to forget is that the modern day matters. And so you want to think about, well, what is happening in the modern day at either the location on the quadrangle or in the quadrangle that you guys mapped. I hope that helps. I know that's a lot, but I'm hoping also that because of the range in experiences, this will help those of you who haven't thought about these things more than maybe once or twice. With that, I'll see you guys next week.